What's up, YouTube? I'm Trent Wel-Don. Welcome back to the channel Wel-Don Aquatics. Tonight, I want to talk more of my auto water change system, as well as some test results that I have produced this week, and are kind of fascinating, and answer a question that came up in the comments. That's right, guys. So if you watched my latest video, we talked about my auto water change system, and in part of that video, I discussed how I have my waste water line from my RO unit tapped into the water line system that feeds my freshwater tanks. Now, that water that comes from the wastewater to the RO unit primarily goes to the 220 gallon. The pressure behind it is going to feed mainly this one. It's the path of least resistance for water. And a subscriber made a comment and brought up kind of an interesting topic for me that really piqued my curiosity. So I did what testing I could and had available to me to see if that water was harming my aquarium in any way. So first things first, this is my opinion. This is in my area, so I can't speak for everybody, and I can only have access to what testing materials I have, so this isn't like lab grade testing, but it still, I think, opens up a great topic here and a great discussion opportunity to figure out, is RO wastewater really wastewater? So here is what kicked this off and piqued my curiosity. So a subscriber commented this: I'm not sure it's a good idea to use the water in your tanks. It may be free of chlorine, but it isn't just water that was not purified. It is water that is carrying away the waste from the water that was purified. So for this video, and this may be a long one, so stick with me, but I think it's going to be an interesting one. It's going to be an interesting discussion. I broke this video down into 5 different topics, so kind of 5 parts of this video that we're going to focus in on and answer questions along the way leading up to our test results to see, is that wastewater harming my aquarium in any way, or any, from what I can test. So those 5 parts of this video are: number 1, what is an RO unit and what is RO water? 2, what's the ammonia cycle? 3, I want to delve into and explain my 3 sources of a water change, and I'll explain here in a minute as we break these down further. Number 4, I want to talk about what tests I conducted to come up with my test results. And lastly, number 5 is the actual test results from each individual test that I ran on my aquarium, and really ran on the water sources that I have access to do water changes. So those are the 5 portions of this. So number 1, what is an RO unit? An RO unit is a reverse osmosis unit. You've probably heard that if you have one maybe installed in like your kitchen sink or kitchen tap, to get a more purified drinking water. Think of an RO unit as a massive pre-filter for water. Mainly they're used in the saltwater industry, as what this does is it strips everything out of the water. So from your tap water, you're gonna have additives, maybe some chlorine, chloramine, some trace metals, calcium carbonate, just other stuff, just things in the water that you can actually find in your city's water test report. That's something they have to put out. It's really interesting to look at. I've actually looked at mine for Grantsville, Utah. When I moved in this house, I really wanted to make sure that I had no chloramine in my water and wanted to make sure I had the appropriate filtration for my water. Now, most water sources are treated with chlorine. That's why we use the chlorinator in our tanks when we do water changes. But a reverse osmosis unit is going to take that farther. This is literally going to strip this down to bare bones, nothing. And then in the process of that, that's what we call the RO water. It is fully purified water, has 0 trace elements in it, and it's not going to have anything in it, but that allows you to remineralize that water with your choice of product. And that's why it's popular in the saltwater industry, the reef industry, is then now they can take their marine salts, mix it back into it, and remineralize it towards their corals and fish for what they're after. Now, this is also going to be used in a lot of like shrimp tanks. I know if you get into the crystal shrimp, they need to have Flip Aquatics explains this really well. He uses a certain remineralizing agent. God, that's a lot of words in one string there. To allow it to, again, though, to give him the proper minerals that those shrimp need in order to have a healthy lifestyle. Now, a reverse osmosis unit can also lower the pH some. So it's really a gigantic pre-filter for your water before it hits your tank. And then part of that is you're going to have the wastewater that's going to be coming off of that. Now, as your tap water passes through, it's going to hit all your filters. I have, I think, a 4-stage filter. You can make these things up to like a 7-stage filter to really pull stuff out. My water doesn't have a lot of stuff in it, so a 4-stage works great for me. But when the wastewater is, the filter is going to judge. It's going to have a purified section and a waste section. That's why there's a RO line and a waste line. Your RO water is going to be the fully purified water that comes out of that filter. Your wastewater is going to be what the filter rejects. It's what it was not able to fully purify before it goes to your tanks. Therefore, it's called wastewater. Now, this is what the main purpose of this video is. I went in and wanted to explore, test, find out, was this harmful to my aquarium? I saw it as I'm literally wasting water where I could be using it to perform a water change on my tank, which then, you know, I'm not necessarily wasting that. I'm adding an additional water change to my tank this week, therefore keeping the parameters more stable. Now, we've now delved into what an RO unit is, what the RO water is. Now let's delve into the other parts of this and really find out if that RO wastewater is damaging the parameters in the aquarium behind me. So the second thing we're going to talk about here real briefly, we've touched on this and this is discussed widely across this hobby, is the ammonia cycle. I wanted to include this in this video just as really a good baseline to understand what we're testing for and also if this really will affect what's in my water. Now you can test, if you test your tap water, and primarily you're going to be testing for ammonia, nitrite, and nitrate. Now that is the process of what ammonia breaks down into. Fish go to the bathroom in your tank. You add fish food in your tank, that's going to break down. This is why we call it the ammonia cycle. It's going to start out as ammonia, which is very toxic to your fish. Your beneficial bacteria in your tank is going to break that down to nitrite, which is still toxic, just not as toxic. And then it's going to break down further to nitrate. And this is where a lot of people in freshwater hobby, like myself, we use plants. Plants eat nitrate. It's going to help reduce that overall ammonia effect in your tank. Now, part of this too is some people will test their tap water and they'll have 1 part per million, like 1 part per million ammonia or 2 parts per million ammonia. That's how it's measured. And there's dechlorinators on the market that can help detoxify that ammonia. Oftentimes we're going to do water changes like we're talking about here. We're talking about water changes. Water changes can remove the ammonia, the nitrites, and the nitrates. And then as you add in fresh water, you're now going to be balancing that. So let's say you tested your tank water, you have 1 part per million ammonia. Most likely you can have somewhere from like 20 parts per million nitrate. There's some rough numbers. You have to do some of your own testing to find out what your tap water is coming out at. But now, what was my wastewater coming out at? So I found the baseline for my tap water. I want to know what the RO water was coming in at. So that's the real brief ammonia cycle. Ammonia, nitrite, nitrate. We can remove all of that through plants, water changes, and beneficial bacteria. Now we're focusing on water changes, so let's continue. The third thing of my testing here was that I want to address is I have really 3 sources that I can do a water change from. So the first one that I was using was my homemade Python system that I've done a video on, we talked about. That is straight tap water. So that's coming out of what I can tap into my water line here in my house. And so that was, I did a baseline testing on that. So there's the first source, is straight tap water. What is that coming in at? And now on that water, I was using a commercial dechlorinator to make sure there's no chlorine in it, and never had any adverse effects doing that. The second source is when I set up my auto water change system. So that's tap water, but first it's going to be run through a sediment filter and then a carbon block And that carbon block is going to remove any ammonia in there, any chlorine in there. It's gonna pull all that out, and I wanted to make sure that was happening. Now, fortunately, just a kind of a bit of a teaser, I do have 0 parts per million ammonia in my water, so I was primarily filtering out for chlorine and any chloramine in my water. I did get a carbon block that would pull out any chloramine. It's actually a harder type of chlorine to break down into a tank, so I'm very fortunate that I don't have that in my water source, but just to double check, I got that type of carbon block. And then from there, so sediment filter, carbon block, then it hits my tanks. So when I use that system, I'm not using any dechlorinator because the carbon block is acting as my dechlorinator. Then the third source is the RO water waste line. So I'm using the wastewater from the RO unit to feed my tanks on a water change. Now we talked about that briefly of what that is. It's water that was rejected by the purifying RO filter that's not fully purified. But what is that? What does that mean? What does it mean it's not fully purified? That's what I really wanted to test here and find out. The fourth thing of this video I wanted to talk about is what test did I run? How did I find out if this water was hurting my aquarium, or how did I find out if this was a positive thing to use on my aquarium? So I tested for TDS, I tested for ammonia, nitrite, nitrate, pH, KH, and GH. Now that's a lot of big words, a lot of fancy syllables. Let's talk about that real briefly. TDS meter. What is a TDS meter? What is TDS, period? A lot of good videos on these out in the world today. A TDS meter is something that's going to read what we call total dissolved solids in your water. Now remember we talked about the first of this video, there's stuff in your water. It's going to read that stuff. It's gonna, it breaks it down to what ions and particles are floating around in your water. A really interesting test to do is if you test your tap water for TDS, total dissolved solids, you're gonna get a certain number. Add some fertilizer, like aquarium plant fertilizer to that water, that TDS number is gonna jump up because now you've added something to that water. So that's what we're talking here. Let's say it's nitrates, let's say it's ammonia in your water. It could be some metal, it could be, calcium. It's all these different things in your water. We don't know exactly what they are, but it's giving you an idea of how much stuff is in your water. So that's what TDS is, total dissolved solids in the water. And I also test, so I did, like I say, I tested my three water sources on each of these. I used an API master test kit to test for my ammonia, to test for the nitrite, and to test for the nitrate. Now again, that's the ammonia cycle. So you can test to see how far, and how fast that ammonia is breaking down to the nitrate version of it. So I ran those tests, and then I used the API KH and GH test kit to find out the KH and the GH. Now the KH is carbonate hardness. It's how much calcium carbonate is in your water. Really big word, do some research on it. It's kind of hard to find out exactly what that is, but it's gonna help you understand. When we talk about I have really hard water, I have really soft water, that's kind of what this is helping you understand, is how much calcium carbonate do you have in your water. So you may hear people say, I have calcium deposits on my tank. I have hard water here. That's what I'll tell you now. So I get hard water spots on the front of my glass if I drip water down and let it sit for a few days. That's a calcium deposit. Now the GH is the general hardness of your water. That's when we're talking, it's the concentration of calcium. Is my understanding, the best way I can explain it is how much calcium is in the water. So it's KH is the measure of carbonate hardness, GH is general hardness, but how much calcium is actually in the water. So now that we've gone over all of that, we have run through what an RO unit is, what an RO water is, what wastewater is from that RO unit. We've talked very briefly on the ammonia cycle. We've explained the 3 sources I have to do a water change with. We've talked about what tests I ran on each source. Now it's time to get into what are the actual test results. I mean, this is what everyone's been waiting for on this video. Let's find out if the RO wastewater really is wastewater. All right, so first we are gonna start with my tap water. This was kind of my control test, my baseline test to kind of see what does it fluctuate on the other 2 sources. So first, the TDS, total dissolved solids, was 303. 303. Moving on to pH, I have relatively high pH. My pH is 7.6 out of my tap. I have 0 ammonia, 0 nitrite, and 0 nitrate. I'm very fortunate there. The only thing I would like to see is I've had like 10 parts per million nitrate actually coming in my tap water, because that now will be like free plant fertilizer. So that's one reason why I do dose fertilizers. I have 0 nitrates coming out of my water. The KH was 10 and the GH was 23. So there is the tap water parameters from what I can test here. Say this isn't a scientific lab grade test. This is what, as a hobbyist, I have access to test. Moving on, let's now focus on to what my auto water change system will do. That's where it runs through the sediment filter to the carbon block, then to the tanks. Let's see what these numbers come in at. The TDS was 303. Same TDS is my tap water. The pH 7.6. The ammonia 0 parts per million. Nitrite 0. Nitrate 0. And this is where it kind of gets interesting. The KH is the same at 10. But the GH is actually 2 points higher at 25 versus 23. Now that could be a user error on the actual test, so they're really relatively similar on that portion of it. So I don't have a test really here to test for chlorine of that nature, but to show you the parameters I can test for from the tap water to the auto water change system water is relatively the same. The only difference is all the chlorine is going to be pulled out of that. Now let's move on to the RO wastewater. This is where it really gets interesting, and I'm not going to say I necessarily prove somebody wrong, but I think I've opened up an avenue for a greater discussion on this and get other people's opinions and feedback on this. Is RO wastewater really wastewater? The TDS, and this is interesting, the TDS is 393. Now with an RO unit, what it produces is if your RO unit is functioning properly, your true RO water should read at 0 TDS. So that shows you how much waste is kicking out of that on the waistline. 393 total dissolved solid particles. That's 90 points higher than my tap water or my auto water change system. The pH is a little higher. It's 7.8. So 0.2 higher than the tap water or the auto water change system. The ammonia, nitrite, nitrate are 0 as to be expected. That's definitely still getting filtered through, so that's going to get kicked out. The KH goes up to 15, 5 points higher, and the GH goes up to 30. So what I have found here, and this is my opinion. My opinion on this test is the RO wastewater is not really wastewater. How I'm utilizing it will not cause any issues in the tank behind me or any of the tanks I use. Now here's my explanation, here's my opinion on why I'm okay to be doing this and why I think it's actually kind of a good idea. In essence, I'm repurposing what was once just going down the drain to help on a water change system to help with overall parameters in my tank. Therefore, I could potentially even extend how long I have to do water changes, but you kind of get where I'm going with this. So with the TDS being 393 versus 303, so 90 points higher, it's not an outrageous jump. If that had jumped up to, let's say, 500, maybe 600, maybe even like 450, like actually over 100 points higher, I may start questioning it further, because that's showing I'm putting more particles, more of dissolved solids into my tank. But what's interesting with that is I've seen some decent plant growth, particularly on the willow high grow I have in here, and it makes me think that it's not harming the tank at all. None of the fish have acted strangely. The Mabu puffer eats like a champ. He's extremely active, so I've noticed nothing wrong there with the total dissolved solids entering the tank. pH could be an issue. If this pH jumped out at like 9 pH, that's going to be a really high swing from a normal 7.6 pH up to that high. But being it's only 7.8 versus 7.6, it's probably really going to average out to a 7.7, if anything, in this tank, which I'm okay with. It's not an alarming number. And the reason I say it may bounce out to that is it's not like 100 gallons of wastewater going into the system. Relatively, it could be maybe 20 gallons at a time, so it's nothing catastrophic that's going to fluctuate it that far off. Now with the ammonia, nitrite, not worried about it. It's already coming in at 0. These are gonna be at 0. The only time I may even get readable nitrates in this aquarium is after I dose a heavy session of fertilizer. But other than that, no effects there. Then if we move on to the KH and the GH, that's proving that the RO wastewater is harder, in general harder than what I am producing out of my auto water change system or my tap water. But with, again, it's even 5 points higher in the KH, so, and then it's, I'm getting a little more calcium in there, and then I'd have another, 23, 7 points out of the GH. So overall hardness of this, again, not a major swing. It is proving that the water coming out of there is harder, but it's not these catastrophic numbers that's alarming. And again, I'm really only producing RO water about once a week right now. And even at that point, I produce anywhere from 5, maximum 30 gallons of RO water. Now, depending on how much of that is, it would be interesting to run another test to see how much actual RO wastewater I produce in that session. And then potentially we could even break this down further. But for right now, an educated guess on how much RO water I'm producing, let's say at 5 gallons, I may get a 1 gallon of RO water, wastewater going into the system. At 30 gallons, maybe 3 to 5 actual gallons of RO wastewater going into the system. So it's not, again, nothing that's gonna be done, like doing a 50% water change or an 80% water change, where that would fluctuate the pH a lot. That would fluctuate the hardness a lot. That could potentially be damaging, but for what I'm using this for, I think I'm actually utilizing water more efficiently by using my RO waste line. So there you have it. Thank you for sticking through me with this. I know this was a longer video, and this definitely wasn't a video of, look at this, look at that, so shiny. This was more of a video of, let's delve into some numbers and answer that comment we got on here. But again, I have to say this, that comment, I did not take it negatively. If anything, that comment sparked this idea in me and sparked my curiosity of, let's do some testing. Let's really figure out if the RO wastewater truly is wastewater, or if I've been utilizing it in possibly a new fashion that could help other hobbyists. So I'm not gonna publicly say who commented that, but thank you though. I do appreciate the insight. I enjoy that the comments come in. I read every comment on my videos because it helps me learn. It really does. If I hadn't seen that comment, I wouldn't have run this test. Then I would have never have known. For all I know, I would have been damaging my aquarium. But now I can say confidently with the test I've run, I feel very comfortable using my RO wastewater in my water change system. So thank you again for everybody for joining me. I'm Trent Wel-Don with Wel-Don Aquatics, and I truly hope that I've inspired you to try something new and experiment in your hobby and find some new results for yourself. So thank you everybody. I hope you all have a fantastic night. Enjoy your aquariums. We'll see you on the next one.